Okay, so I've talked a bit about discount rates, but one of the things I haven't talked about is how you actually decide on it. And it's actually not an easy decision. And in all of the questions I give you, I always give you a discount rate because it's pretty arbitrary what you choose. Now, because I have a mortgage, we own a house, or a small percentage of the house, and we're paying it off. Any money that we I basically use our discount rate as the mortgage rate. Somebody who doesn't have a mortgage, who could put money into an investment account, which actually earns less than a mortgage, your discount rate would be a little bit lower. Or if you're going for high-risk things, that maybe your discount rate could be higher. So basically, how you work out your discount rate is your rate of return for the best alternative use of funds. For example, e.g. an investment account. Now, those of you who are doing economics will have heard of the idea of an opportunity cost. Okay, if I buy a car for $10,000, my granny dies, gives me $10,000, I go out and buy my car, I say, no, I'm not paying any interest on that money because I just got it, and so that car isn't costing me any money. But it is, because there is the opportunity cost of what we could do with that $10,000. If we put it into a reasonable sort of investment account, we might be able to earn 7%. So in fact, that car is costing us 7% of $10,000, which is $700? Yeah, something like that. Anyway, I can't do maths in my head in front of people, it's too tricky. But anyway, you've got that money, and that's what the cost of the money is to us. It's an opportunity cost. No money ever changes hands. Nobody comes and says, oh, look, give me your money for the money that's tied up in your car, but it is still a cost. And it should be taken into account when you're setting up a business, because a lot of people mistake that. They think, oh, look at all this profit I'm getting, but in fact, they may well find that their profit is less than what they would have got if they had simply stuck that money into a bank, which is much safer, generally. Okay, another way of choosing a discount rate is a desired rate of return for a project of equal risk. And this is a management policy choice. So whatever company you're in, and it may be your own company, is that you will decide, well, if a project's really risky, I want to have a high rate of return. I want like 20% return on my investment. If it's very low risk, maybe I'll go with 10%. But if it's high risk, it's got to make up for the fact that you might actually lose that money. Okay, now another one is an average financial cost of capital for the organisation. So companies who borrow money, as they all do, to fund their organisation, have borrowed money from various places at different weights, at different amounts. So what you do is you have a weighted average. So whatever source has the most has the highest weight. So we end up with a weighted average over all sources of funds. This stuff is in multiple choice questions on the quizzes, but there's not many of them, so you'll learn them off by heart pretty fast. There are whole courses on how to choose a discount rate. There's one APHIS paper specifically about that. And anyone who's studying finance, this is the sort of thing that they spend a lot of time working on, what discount rate you choose. Because you can see from the things I've shown you earlier that your discount rate is going to affect your decisions enormously. Okay, because when you come to accepting a proposal, this is the criteria you use, or these are the criteria. If the net present value using your chosen discount rate is greater than or equal to 0, so if you have a positive net present value, then you would go ahead. Or if the internal rate of return is greater than R star. So R star is your discount rate. It's your chosen discount rate. So if it's going to have a net present value which is positive, you would probably go ahead, or if the internal rate of return is more than 0. Those two statements are equivalent, but just sometimes we use internal rate of return and sometimes we use net present value. Now there's a big proviso here, is that note that this is only looking at the financial aspects. Because there are always other reasons why you would or wouldn't take part in a certain investment. It might be that you are ethically opposed to the thing, and so you wouldn't do it even if it was worth a whole lot of money. Or if it was something that you really believed in, even if it was going to cost you a little bit of money, you would still do it. Or if you liked risk a lot, you might go for a high risk thing, or if you dislike risk and so on. So there's a whole lot of other aspects. So how you choose between projects is you go for the highest value of the NPV. You also have to take project mix into account, and we're not touching on that in this course, but we'll be talking about that in MSci 101, which you then do by finding the highest equivalent annuity, and you use other considerations as well. Right, this is the extra bit, which will help you with the test. Basically, here's some examples that you'll get in the quizzes. And what you have to do each time is you think to yourself, is it a single cash flow or is it a series of cash flows? Am I interested in the present value or the future value? And if you answer those two questions, and there's one more, if it's a cash flow, you can decide, am I interested in the payment or a present value or future value? If you can answer those questions, then you can just use the correct formula and answer it in Excel. So here's our first question. We're going to deposit $50 per month for 5 years. How much are we going to have at the end? And we'll say this is at 10% per annum. Okay, so you ask the first question, is it a single cash flow or is it a series of cash flows? Okay, put up your hand, is it a single one? Is it a series? Good, okay, it's a series of cash flows. So first of all we say it's an annuity. Okay, now, do we want to have future value or present value here? Hands up if you think it's going to be future value. Hands up those who think it's going to be present value. Okay, those of you who had an opinion were correct. It is future value because it says at the end. So what we want to do is we're going to find the future value. So we trot over to Excel and we put in equals FV, open brackets, put the stuff in it and get the answer. Okay, next one. You want to have $10,000 at the end of 6 years. What are we going to deposit now? And again, we'll make it 10% for all of these. 10% per annum. Okay, is this a single cash flow or a series of cash flows? Hands up if you think single? Yep, you're right, it's a single cash flow. Because we're just saying, what are we going to deposit now in order to have $10,000 at the end? Okay, so are we wanting present value or future value? We want future value, but because it is a single cash flow, we don't use the FV formula. So it's not FV on Excel, but what we use instead is that we go $10,000 times 1 plus 0.1 to the power of 6. So when you do it on Excel, but you don't use the FV function. So it's a single cash flow, so we use this formula. If it's a series of cash flows, then we use the FV function. Okay, we're going to buy a car costing $10,000. We're going to pay fortnightly. What are the payments over 5 years? Okay, is this a single cash flow or a series of cash flows? Series of cash flows, because we're going to be paying fortnightly. Every 2 weeks we're going to pay some money. So we've got, it's an annuity. Okay, do we want the present value or the future value? Okay, neither, actually. We have the present value. The present value equals $10,000. Okay, what is it that we want to find out? It's the payment. So we go PMT for payment, open up our brackets, stick the bits into Excel and get the answer. So the trickiest part is looking at the questions, deciding is it a single value or is it a series of cash flows? Oh, and there's one more actually, which is, I'll find some more spare paper. Say that there are cash flows, so you deposit, oh, sorry guys, put it back. Deposit 5,000 now and 7,000 in 2 years. Get back 20,000 in 5 years. What is the present value of that? Can I take this one away now? Okay. Now, is that a series of equal cash flows or is it a single deposit or is it neither? It's neither. It's a series of cash flows. We've got 5,000 going one way, 7,000 going the same direction, and then 20,000 coming back. But it's not an annuity because it's not equally spaced and it's not equal amounts. So what we would do is that is a net present value. And so what we would find is we would go $5,000 divided by 1 plus I to the n, which in this case is 0, plus $7,000 divided by 1 plus I to the n, which is 2, and then actually those are both be minuses because they're going out, plus $20,000 divided by 1 plus I to the 5. And all of that would give us our net present value, and you can do that on Excel. So that's what you want to learn in your tutorials, is how to do it on Excel so that you can do it easily, and that one has to be done by the end of week 1 of next term. Okay, thank you for your attention. Next, tomorrow's really cool, it's probability. It's my favourite topic.